Let's move on to the next related rates problem. In this next example, a boy flies a kite at a constant height of 12 meters, and the kite is flying horizontally at a rate of 5 meters per second squared. Okay, so if the kite is flying at a constant height of 12 meters, that is being represented by this distance right here. So that vertical distance is 12 meters. And then the kite is also flying horizontally at a rate of 5 meters per second. So what that means is the kite is flying in the right direction. So let me kind of label the horizontal direction using the variable x. So if the kite is moving horizontally at a rate of 5 meters per second, and if x represents my horizontal distance, that means that dx over dt equals to 5 meters per second. Now for the problem is asking how fast is he letting out the string when the kite is 15 meters away from him. Okay, so in order for us to get this problem going here, we should definitely label the rest of this triangle diagram. So this vertical distance I'll label y, and the distance between the boy and the kite is that red line, which I'll label as s. So maybe s is kind of like the length of the string, but that also represents the distance between the boy and the kite. Okay, so for this particular problem, I want to find out how fast is he letting out the string. So my string is denoted s, so I need to find ds by dt. That's what I'm trying to find. And I need to figure out that when the kite is 15 meters away from him. So that means s equals to 15. So when the string is 15 meters away from him, then I want to find out what ds over dt is. Okay, so let's try to figure this all out. The formula that would kind of connect this particular diagram is going to be the Pythagorean Theorem again. So my variables are x, y, and s. So if I set my Pythagorean Theorem, that's going to be x squared plus y squared equals to s squared. And for my y, although I have the variable y there, y is actually the height of the kite. So throughout this problem, the kite will remain at 12 meters. So I can replace the y with the constant 12, so 12 to the power of 2. And let's go ahead and take the derivative with respect to t. So if I do that using the power rule to start, that's going to be 2x times dx over dt. The derivative of a constant is going to be 0, so that just goes to 0. And that's going to equal to the derivative of s squared with respect to time. So using the power rule, that would be 2 times s times ds by dt. So there is my derivative with respect to time. And let me just erase that. And then usually with these related rate problems, what we're going to do next is we're going to start plugging in the values that are given to us in the problem. So I know dx over dt, which is 5. 5 is going to go over here. This s equals to 15, that's going to go down there. Our goal is to find ds over dt, and then I need to figure out what's happening with this x variable here, and hopefully we can figure that out. One more thing that you might want to do is you can cancel out the 2's. The 2's can cancel off, so I don't need that anymore. So let me erase that. So what we need to do now is we need to find out what x is. Okay, so in this problem, we know that we got to find out what ds over dt is when the kite is 15 meters away from him. So what you can do is you can kind of create yourself another triangle where we know the height is always going to be 12, but the distance between, the kite is always 15 meters away from him. That's when we need to find out what ds over dt is. So we're going to assume that this is going to be 15. So that's this 15 right there. And what we need to do is I need to find out what this horizontal distance is. Once I find that horizontal distance when the kite is 15 meters away from him, I can use that horizontal distance and plug it in there, and that will allow me to find what rate the string is coming out at. Okay, so let's go ahead and use the Pythagorean Theorem and find out what the x value is. So that's going to be x squared plus 12 squared equals to 15 squared. And if you do the math on that and do this correctly in your calculator, x is going to equal to 9. So I'm not going to do all the work on that. I think most students should be comfortable with that. And then let's plug in 9 over here. Let me erase that. And let's plug in the 9. And let's go ahead and plug in the rest of the numbers then. Okay, so let me just kind of clean this up here. This is going to be 9 times dx over dt. So that's going to be the same thing as 9 times dx over dt, which is 5. And then that's going to equal to s, which is now going to be 15 times ds over dt. So now I need to solve this particular equation here, and then the problem is solved. So that's going to be ds over dt. And then I have my 9 times my 5. And then the 15 can go underneath. So divide by 15. And you can jump to your calculator, or you can do some simple math here. I guess 5 and 15, that's going to be 1 and 3. And then 9 divided by 3 is going to be 3. And my units are meters per second. And that's how you solve part A of the problem. All right, let's take a look at problem B now. And problem B is, how fast is the angle between the string and the ground decreasing when the kite is 20 meters away from him? Okay, so let's figure out what the angle is between the string and the ground. That's going to be this angle right here. And that angle is going to be decreasing as the kite goes further to the right. And if I just draw a little diagram illustrating that, hopefully students can see that. So if the string keeps on being released and you're maintaining this 12 meters vertical distance throughout the problem, hopefully you can see that this angle right here is actually getting smaller and smaller. So if I release more string and we continue to maintain that 12 meters of distance, the angle is decreasing between the string and the ground. So we should definitely expect a negative answer for this particular angle problem. Now, when you're doing these angle kind of problems, you always want to take the information that's given to you at the start of the problem. So at the start of the problem, we're given the constant height of 12, and we're also given this horizontal rate of 5 meters per second. So I'm saving my horizontal rate of 5 meters per second, and we're also going to save this 12, and we're going to be using that to set up our next equation here. If I'm given that my horizontal rate is 5 meters per second, make sure that you actually use that variable when you label your diagram. So make sure you have an x there, because dx over dt is going to be 5. And we know that throughout the problem, the vertical distance is always going to be 12. So make sure you use that in your diagram as well. Okay, so if I take a look at my triangle diagram here, I have my angle, and I have an x variable, and I have 12. I need to find a mathematical formula that connects the angle, the 12, and the x. And that's going to be tan theta, because this is your opposite, and this is your adjacent. All right, so I need tan of the angle, and that's going to equal to my opposite over my adjacent. My opposite is 12, and my adjacent is x. So this is the mathematical formula in which I'll take the derivative with respect to time, and then I'm going to plug in my my variables and my numbers, and I need to find out what d theta over dt is. All right, so let me kind of write down d theta over dt. That's going to be equal to a question mark, and I need to find that when the kite is 20 meters away from him, so that means s equals to 20. Okay, but the formula that I do need here is my tan theta equals to 12 over x. Okay, let's take the derivative of this with respect to time. So the derivative of tan theta with respect to time is going to be secant squared theta times d theta over dt. And regarding the 12 divided by x, you can think about that as 12 times x to the power minus 1. So if I take the derivative of that, that's going to be negative 12 x to the power of negative 2 times dx over dt. And if you want to just simplify this part here, you can put that on the denominator as x squared. And let's just erase that. And I'll put my dx over dt a little bit closer. Okay, let's try to figure out how we can solve the rest of this problem here. If I'm dealing with secant squared theta, remember secant theta is the same thing as 1 over cos theta. And I recommend that you do write the secant theta in terms of the cos theta. So if I do that, secant squared theta is now going to be the same thing as 1 over cos theta. And all of this is being squared because you have a power 2 there, times d theta over dt. And that's going to be equal to negative 12 over x squared times dx over dt. Okay, after that, we need to find the missing numbers and variables, and then we can probably finish off the rest of this problem here. I'm going to just redraw my triangle here. That's going to be 12. And in this particular problem, remember, we got to find out how fast the angle is between the string and the ground is decreasing when the kite is 20 meters away from him, right? So s is equal to 20. So let's put the 20 over here now. And then I want to find this x here. The reason why I'm trying to find that x there is because this x is connected to that x right there. Okay, so let's go ahead and use the Pythagorean Theorem here. So that's going to be x squared plus 12 squared equals to 20 squared. And if I do that, x in this case is now going to equal to, I believe this is going to equal to 16 if you use your calculator. So make sure you do verify that with your calculator, but I do think 16 is the right answer. So let me put a 16 there. And what we're going to do now is we're going to plug in all the missing numbers. Remember, this is our main goal is to find d theta by dt. And one more thing that we may have to kind of simplify is cos theta. So what is cos theta? Okay, well, look at your diagram here. This angle represents that angle right there. So if I look for cos theta is your adjacent divided by your hypotenuse. So my adjacent is going to be 16, and my hypotenuse is going to be 20. So cos theta is a ratio of the adjacent and the hypotenuse. So if cos theta equals to 16 over 20, I can put that into my formula now. So instead of writing cos theta now, I can write 16 divided by 20. Remember, the ratio of cos theta is now 16 divided by 20. And let me just erase that. And if you had to kind of simplify this again, this is the same thing as now 20 over 16 all to the power of 2 times d theta over dt. That equals to negative 12 divided by, well, what was x again? Well, x was 16. So that's going to be 16 to the power of 2. And then I need to find dx over dt. And in order to find dx over dt, I need to go back to the beginning of the problem. Here's my dx over dt. It's 5. So the 5 comes down there. So I need to multiply that by 5. Now that we have all the numbers put into place, we can go ahead and now solve for d theta over dt. There's different ways of doing this, but I'm just going to put all this into my calculator there. So negative 12 times 5 divided by 16 squared. If I get that result with my calculator, I get negative 15 over 64. And then I'm going to take my calculator and I will evaluate that answer right there. So 20 over 16 to the power of 2. And if I convert that into a fraction, I get 25 over 16. And there's different ways that you could definitely figure out the answer here, but I'm just going to use my calculator just to save a little bit of time. And then I guess I can bring this to the other side, and that's going to be negative 15 over 64. And basically you're now multiplying by the reciprocal now, which is 16 over 25. And then I would go to my calculator and just get out the final answer here. And my final answer there is going to be negative 3 divided by 20, and that's measured in radians per second. All right, so that's it for that particular video. I was a bit sloppy with organizing some of the key facts, but if you go back and rewatch the video, I'm sure that you can definitely work out the numbers and the steps. If you have any questions, just let me know in class.